Again, we're looking at our terminal start for these. T moves along the unit circle. It is positive if the terminal point that we're looking for is positive. We know it's going counterclockwise, CCW, meaning we're going counterclockwise in reference to that starting point. If it is negative, and we'll talk about those, if it is negative, we're going to move clockwise down below. The point we end up is called the terminal point. So we're going to reference these. This is kind of spinning around the unit circle, and we're finding these coordinate points that exist there.
Is the starting one after 0, move T along into 1?
And it's always going to be our starting point. 1, 0 is our starting point for this. So it's our terminal start. That's what we always are going to start out with. Can I move on? Try some of these out so we can look at them. So a lot of you guys still copying those down. Okay, let's look at solving some of these and what type of problems we're going to look at. Copy down these 4. These are the basic ones that you see on your guys' paper. We're going to change up one of them so that they're negative here. And we'll change up this one so that's negative. I'll reference them. Examples of terminal points. And I want you guys to kind of draw a rough graph of these. Right, there's not that much intricateness to it, but I do want you guys to start seeing what we're doing here, how we're finding these terminal points, using T as our reference. You guys definitely have them on the unit circle here. Okay, and if we look at closer to the inner circle is going to be our degrees. Then extending out for them is our radians. And then from those are the terminal points, our coordinate points on our unit circle. Looking at the first one, we first want to be able to identify one thing. Is it positive or negative? Positive. Since it's positive, what direction are we going? Counterclockwise. This is important when we're looking at different things. And our starting point is always going to be at 1, 0. So if we're going clockwise by pi over 2, where should our ending point be? Positive 1/2 here, right? Because it's looking at your unit circle, look where the radians are at.
Oh.
We're moving along the unit circle. Okay. What's our coordinate point for that? What's the coordinate point, Luke?
0, 1.
0, 1. So in reference to this, we get that since T is equal to pi over 2. Our point that we're going to reference is 0, 1. And this is actually looking at the beginning stages of graphing and sine, cosine, and tangent. Hoping you guys are. I don't know whether Mr. Scranton gave it to you guys. You guys should know about this. I know you guys definitely covered a whole unit on this because I know Miss Mann did it where she gave you a blank one of these and went, fill it in. You know, Miss Williams did it to everyone. You guys already did this. Whether go into more intricate types of problems than you relearning the unit circle. So, yeah, use it. Okay. Looking at our next one. T is equal to pi. Is this positive or negative?
Positive.
It's positive again, so we're going to go counterclockwise. And we're going back pi units. So we're going to go back a full half rotation, or a half rotation, sorry, not a full rotation. Our terminal point is going to be there, which is going to be what value? Negative 1, negative 1, 0. So T being pi is going to give me my terminal point of negative 1, 0. This is all you really got to do today. Find the terminal points that exist between these. The next thing we're going to do is our last two. Looking at this next one, is our T positive or negative? Negative. So since it's negative, we're going to go clockwise. So that means we're going to go down first. Looking at this reference, we're going to go 3 pi over 2 units around. So this is actually going to be a half a pi, a full pi, and 3/4 pi, or 3 pi over 2 pi. Okay, so we're going to kind of look back at this reference point. We're going backwards, clockwise. If we do it clockwise, what's our value here? 0, 0, 1. Therefore, our terminal point is going to be 0, 1. Now, if you're looking at the first one going, well, we're getting two of the same answers. Yes, but we're going negative. So because we're going counterclockwise, if we went clockwise, you're absolutely right. We would go back up here and go down. But it's not going to be always the case if it's negative. We're going counterclockwise. So we're going pi over 2, 2 pi over 2, 3 pi over 2. Going the other way.
So it's not, we're not going to the point that's giving, we're going that amount.
That amount. We're going that distance around the unit circle. And it depends on whether it's positive or negative. So even though the top says it, like in the beginning, it says that it's, right, we're going 3 pi over 2 units from the terminal start, where we're starting from. So this is where it can try to get tricky, because some of you guys are going the traditional clockwise away around. What I would do as references is go, how do I go from here down, right? Go 1, 2, 3. So then I'll start back, and since it's negative, I'm going to go 1, 2, 3. Just go the other way. Whatever's going to take you to go the other way. The next one that we're getting here, this is our final one here. This is also negative, so we're going to go clockwise. Terminal start is here. We're going to go 1 full rotation back, around, which is going to get us back to our start. Negative 2 pi is still going to be 1, 0. Good stuff? So we should remember a lot of these things, even though I'm kind of reviewing it a little bit. But we're going that distance around. T, we're going distance around the unit circle. You guys remember doing it?
No, I don't.
Okay. Some teachers covered a little bit more than others. Okay. Let's just finish up these three. Then we're just going to finish up our last portion and we're done. It's going to be a little bit nicer for us. Find the terminal points on the unit circle determined by the real number t. So it is some t length units away. Find the terminal points on the unit circle determined by t. Is t positive or negative? Therefore, we're going to go what? Counterclockwise, meaning we're going to go backwards. Starting off here, this would be pi units. This would be 2 pi. And if we do one more half spin around, we're going to end up with 3. It's going to be a spin, one more pi units around. What point is that? Again, we're traveling that distance around our unit circle. So you definitely want to be able to see how it's referenced, where we're moving to for each pi, pi over 2, pi over 6, 7 pi over 6, depends on what I can give you. So you want to see that distance around. The next one we're getting here is negative, so that means we're going to move clockwise. Starting at our starting point down here, I'm going to be going down, pi distance around. So that is a pi distance around here. We're going to end here again. And it's going to give us negative 1, 0. Yes.
So every half of the circle is 1 pi.
Every half of the circle is 1 pi.
And every time it's over a 2, that means it's a quarter of the pi.
Yes, it's a quarter of the pi. Each distance around, you can think of it like each length around, for us reference, is pi over 2. So this would be another pi. This would be another pi. This would be, right, so as we go around, each of them is a quarter of a turn. Now, it's not going to be so nice. It's not going to be so nice, but, you know, we can still use this as a reference. And I'll show you how it's a little bit easier to see it with the ones that are in between. Right, so I'll kind of show you guys how to do those. Okay, so we should be good with those, right? Pretty straightforward? Pretty straightforward. Let's go ahead and look at the next ones. Don't worry about that. Don't worry about that. Okay. There's a reason why I'm skipping that over. Now, what happens if we're finding terminal points that are not at x and y coordinate, they're coordinate planes, right? They're not at good vertice points. We want to be able to reference our chart here. Yes, we're going to look at these right now and do them. This is the basic start to the unit circle. I just kind of wanted a review of how to actually get that. When looking at these, the way that I kind of remembered is the first thing is for each of our terminal points, they're all divided by 2, right? They're all divided by 2. Yeah. Once you kind of see how it's all done, it's kind of referenced pretty easy. And then what you get from here is that your coordinate points that are going to lead up from these, it's kind of interesting, but if you think about it, we can reference this even further, that our x points go from top to bottom. It starts at, like the square root of 1 is just 1, square root of 2, 3. So 1, 2, and 3 are going to be in our first position. And then if the y coordinate point is going to go backwards. So it's going to go backwards, so it's going to be square root of 3, square root of 2, square root of 1, which is still 1. So 3, 2, 1, 1, 2, 3, just depends on where your location is. And then those transcribed, these transcribe into our points across our mappings. And depending on the location, whether we know that both of our points are positive, negative and positive, negative and negative, and positive negative will determine those values of which are positive or negative. So that's another way to look at it. Again. Always. 1, 2, 3, 3, 2, 1. And once you kind of map it, I always did it just mapping them this way, and then I just map them downwards and then map them across. Or you can map them down, but it doesn't matter. There's 2 ways you can do it. Okay. So depends. Yeah, for the starting position for our points, when you start switching up points and you're going in a different direction, it looks a little bit different, but it's essentially the same thing. Okay. So again, you guys have this. I'm not too worried about it. We'll talk about it if we need to further. When looking at our coordinate points, okay, let's look at these two. Copy down these two. Okay. These are further examples of finding terminal points using points that are not so nice on our graph. And there's a reason why we're going to look at these. Like, how do I know which, if I'm looking up here, how do I know which one's a pi over 4? Which one do I know these to be? So we'll talk about those as well. The way that I see these ones is a little bit more intricate, and they're going to be a little bit more harder because you want to make sure you're corresponding them to the correct versions. Whatever I see with this, I know, first of all, we can do essentially the same thing. Is it positive or negative? Negative. So negative tells me that I'm going to go clockwise over or clockwise around my unit circle. The next thing I would like you guys to do, and to kind of make this up, is I know that we're splitting this up into fourths, because the bottom of this is in fourths. So if you're thinking about how it's done, we're going to split it up into fourth blocks. 2 pi around gives me 8 different blocks for each part of those. The top number, if there's no number up here, we can always assume it to be 1. So I know I'm going 1 pi over 4 down in that direction. Just another way to look at it. What is the coordinate points for my pi over 4 of that coordinate point? Just another way for you guys to look over it. So again, I'm splitting these up into 4 parts. 4, 5, 6, 7, 8. So those are 4 different parts for each plane. If I'm doing it for my upper portion, for the next one, we can still do the same process. Is it positive or negative? Positive. So therefore, we're going to go counterclockwise. We're still starting off at a reference point. I want to be able to determine which one that would that be. And now you guys do have this on your guys' coordinate plane, right? What is 2 pi over 3? You can just use those points. But I do want you guys to kind of graph it and just how to reference this. Looking at this, what I would do is split these up into thirds. Looking at my first one here. Looking up here. Again, we can split these up into each different groups. Kind of helps you reference where you're located at. And since we're moving clockwise, so this is splitting up the bottom portion. The top portion tells me how much distance I'm going to go around using this pi over 3. I'm going over 1, then 2. It's going to give me this coordinate point up here, which is going to be my reference for what? -1/2, -3 over 2. This will be my terminal point for this. Are we okay? Simple? Simple enough? No? Oh, can't get a read from you guys. Yeah? So yeah, I do want you guys to use this. Cool beans? Yes. We always know the distance around this is pi, right? So what I'm trying to do with this is I'm splitting it up into 4 different parts using the bottom. So that's why I'm getting 1, 2, 3, 4. Because our first one over here, so if you really want to think about it, because I'm going downwards, right, because it's negative, I'm just doing it downwards down here, right? And I know I'm going a pi or 1 pi distance down from underneath it. That's all we're doing, okay? Here's your guys' homework. Check it out. Skip that. Oh. It's a unit circle. You guys already have that. Last 4 problems should be kind of quick. Everything else is for you guys there. So sign up for the first one.